Hello and welcome to the CCNP Routing and Switching course offered by SimplyLearn. The last lesson focused on switch architecture and operation. This lesson focuses on switch port configuration. Let us begin with the objectives of the lesson in the next slide. By the end of this lesson, you will be able to explain the methods to perform multi-layer switch forwarding, identify the fields involved in Layer 3 routing packet rewriting, describe the types of switch interfaces in Layer 2 and 3, configure speed and duplex, explain air-disabled interfaces and re-enable them, configure miscellaneous switch commands. Let us begin the discussion with multi-layer switch forwarding methods. There are two options: route caching and topology-based switching. Route caching combines a route processor and a switch engine. The route processor processes a traffic flow's first packet. Once the destination is known, the switch engine takes over. It places the destination in its route cache and handles all subsequent packets in that traffic flow. Route caching is no longer the default forwarding method for iOS Catalyst switches. However, this is still used to gather traffic flow information, so it is important to understand how the processing occurs. Let us look at Cisco Express forwarding, Cisco's topology-based switching, and how it works. Cisco Express forwarding, CEF, is the second method of multi-layer switch forwarding. CEF forwards packets at line speed with some exceptions. CEF is on by default, and Cisco recommends that you do not disable it. CEF is similar to fast switching in router iOS. It is less CPU intensive than route caching. CEF uses two areas in memory: Content Addressable Memory, CAM, and Ternary Content Addressable Memory, TCAM. Let us look at them in the next slide. Content Addressable Memory, or CAM, holds the MAC address table. It is the primary table used for Layer 2 forwarding. CAM processing returns one of the two values, found or not found. These results are sufficient for MAC processing. Either the MAC is found or not found. Ternary Content Addressable Memory, or TCAM, is different. TCAM processing returns three values: 0, 1, or don't care. This range of results is required for the more complex matching involved in ACLs, QoS, and routing tables. For example, a lookup can be initiated for longest matches, first matches, or exact matches. Each TCAM entry consists of value, mask, and result combinations. There is a special area in the TCAM called the LOU. If an ACL entry concerns port number calculations, as shown in the slide, an LOU register entry is created that includes both the operator and operand involved. The TCAM has a limited number of LOUs. Let us look at the two tables used by the TCAM.